as well at a price of 75. And here are the answers. So let us continue with chapter 3 of the book. And in chapter 3 you will learn two basic things. So in chapter 2 we discussed the basic supply and demand function. But what is added in chapter 3 is answering the question, who benefits from the presence of markets? To which extent do consumers benefit from the opportunity to trade in markets, and to which extent do producers benefit? And we want to develop quantitative measures that measure the amount of benefit that each party derives. Now, once we know the benefits to consumers and producers, we may not be satisfied with the outcome. And policymakers are often not satisfied with market outcomes because they don't deem an outcome fair. They think that the market leads to bubbles. They might consider security risks, and they might want to intervene in the market and to steer it in a different direction. Then the question is, what can the government do? What tools does the government have available? Now, the tools that we will consider in chapter 3 are price regulations, where the policymakers impose a regulation on the price. This may be a price floor or a price ceiling. It can also regulate the quantity. This is what we've observed with the COVID crisis, where the government policymakers strongly regulated who would get the vaccine when. And other often used tools are the ones you're familiar with, like taxes and subsidies. And all these will also be extensively discussed in the tutorial. First things first, let's start with measuring the benefits to consumers and producers. And those benefits are called surplus. So the consumer surplus is the difference between what a consumer would be willing to pay for a good and the amount that he actually needs to pay. So suppose in the summer you would like an ice cream, you crave for it, you would be willing to pay €5 for your ice cream, you only have to pay 2, so the benefit of the trade to you is €3. Now suppose that you would be willing to pay €2 for an ice cream, which is exactly the cost of the ice cream, then it would not be a benefit of trade to you, because yes, you can buy the ice cream, which would give you the ice cream, but also you would lose €2 and you would be indifferent between buying the ice cream and not buying the ice cream. But if you're willing to pay more than you actually have to pay, you will derive a benefit from buying. So how to define the consumer surplus? That turns out not to be too difficult. So we're back to the demand curve that we had in chapter 2. And remember that we started out with the demand choke price, telling you that in this case, at a price of $5.50, no one is willing to buy an apple. But when the price decreases to below $5.50, some people are willing to buy an apple, which means that the willingness to pay of some consumers for an apple is close to $5.50. Other consumers, they also want to buy apples, but their willingness to pay is lower. So if you're at point C tells you that 3 people are willing to buy an apple if the price is $4 or less. But once the price exceeds $4, they no longer want to buy, or some of them no longer want to buy. Now suppose that the equilibrium price in this market is equal to $3.50. It means that the consumer who is just willing to pay $3.50, he's indifferent between buying and not buying, so he doesn't derive any surplus. But for these consumers over here, they derive net benefits from buying apples, because their willingness to pay for apples exceeds the amount that they actually need to pay. They are willing to pay $4, $4.50 or $5, but in fact, because of the equilibrium price, they only need to pay $3.50. So they benefit. So the consumer surplus is given by the yellow area that's depicted over here. And the larger this triangle, the higher the benefit that the consumers derive from the apple market being there. The producer surplus works in a similar fashion. So it's the difference between the amount that the producers are willing to sell the goods for and the price that they actually fetch for their products. And one important note here is that the producer surplus is not equal to the profits of the firms. So you should not equate the two, and we will get into more detail later. So for simplicity, assume that the supply function reflects the supply of many firms and that each firm wants to sell one apple. That's not really realistic, but for expositional reasons, it's a good assumption to make at this point. So the supply function might then look as follows. At a price of $1.50, no firm is willing to sell its apple, but once the price reaches $2, then there's one firm that's willing to supply the apple. So we're at point V over here. Then when price increases further to $2.50, then two firms are willing to sell their apple at a price of $3. Three firms are willing to do so. And then if the equilibrium price is equal to $3.50, a total of 4 firms is willing to sell. They each receive $3.50. Now for the 4th firm, that doesn't bring any surplus, but the other 3 firms, they would be willing to sell at lower prices, which means that if they are able to sell at a market price of $3.50, they derive a net benefit. And the total of these benefits to the producers is equal to the green triangle, and it's equal to the producer surplus. So then that was pretty quickly. So our derivation of the producer and the consumer surplus and the remainder will really be spent on asking the question, what can policymakers do to change the market outcome in a certain direction, and what are the good things about it, and what are the negative side effects of that. Now, first thing that a policymaker might do is to try to influence the price via price regulations. And they come in a couple of flavors. So they may impose a price ceiling, saying, okay, it's forbidden that the price in this market is higher than a certain level. They also may ensure a price floor, saying, okay, the price in this market cannot go lower than this amount. But they're only effective if they're binding. So if they're non-binding, then the price floor is lower than the equilibrium price that would exist if you would just leave it to the market. So what are the impacts of price ceilings or price floors on markets? And that's an important question. And we will go through a number of examples. So how to evaluate this type of policies? The way we do it is we look at total welfare, which is the sum of the benefits of market interaction to the consumers plus the benefits to producers and the revenue to the government, because the government in the end is us. So if the government gets taxes, then it will also spend those taxes and people in society will benefit. Now the deadweight loss is the reduction in total surplus, so the combined surplus of firms, producers and government as a result of market inefficiencies. And the objective is to make these inefficiencies as small as possible. And we have transfers, which is a surplus that before the regulation was in place was part of the producer surplus or the consumer surplus, but after the regulation has been put in place, shifts to the other side of the market. Now, to give an example, and this is an example from the book, we have the market for pizzas, and on this market for pizzas, the policymaker imposes a price ceiling. So, first consider the situation without price ceiling. Then we have the supply function, which is upward sloping, and the demand curve, which is downward sloping. And we can see that if we would leave the market to itself, then the equilibrium price would be equal to 10, and the quantity of pizza sold would be equal to 10 as well. Now, suppose that for some reason the government deems this equilibrium price too high. It says, well, it's ridiculous that a pizza costs you $10, and we will solve that by imposing a price ceiling of $8, meaning that pizzas can never be sold at a price higher than $8. Well, at this price of $8, more people will find it interesting to buy pizzas. So we have consumers who were not willing to pay $10 for a pizza, but at a price of $8, they will be happy to buy a pizza. So at this price ceiling of 8, the equilibrium or the quantity demanded will increase to 12 pizzas. But the problem arises that at this price ceiling of 8, the producers are not that fond of supplying pizzas to the market. So at the old price of 10, they would supply 10 pizzas, but now at the new price, only 8 pizzas will be supplied to the market, or 6 pizzas will be supplied to the market. So in this case, we have a shortage. We have at a price of 8, 10 pizzas will be demanded by the market, but only 6 will be supplied. And that leads to a deadweight loss equal to this pink triangle over here. Because given that only 6 pizzas will be supplied to the market, 6 people who would like to buy a pizza, they cannot buy because they are not supplied these pizzas. And the only consumers that will buy in equilibrium are the consumers with the highest willingness to pay. So the people who are willing to pay most for the pizza, we assume that they are the ones that get a hold on these 6 pizzas that will be supplied, and they will buy the pizzas. And they can buy them at a price of 8. Now, for the people who are able to buy a pizza, this is good news because their surplus increases. Previously, at a price of 10, their surplus was A plus B. But now at a lower price of 8, they get the same pizza, but at a lower price, meaning that some of the surplus that was previously in the hand of the consumers is now transferred to producers, is now transferred to the consumers. So the consumers who are able to buy a pizza under the regulation, they benefit because their consumer surplus increases. And the producers who sell the pizza, they suffer because their surplus is reduced by the area D. But on top of that, we have consumers who would be perfectly willing to buy a pizza at $10, but now because of the price ceiling, those pizzas are no longer supplied to the market, so they leave the market without buying any pizza, and they also don't reap the surplus that they would get from buying the pizza. So that's a loss in consumer surplus of C, which doesn't go to the producers, it's just loss. It is the part of the deadweight loss. On the other hand, there are producers who have a cost structure such that at a price of 10, they would derive benefits from supplying pizzas to the market, but now given the price ceiling of 8, they cannot supply these pizzas, leading to a loss in the producer surplus equal to the area E, which also counts as part of the deadweight loss. So Because of the price regulation, previously we were at point W, we didn't have any deadweight loss. Because of the price ceiling, we're now in the situation where the new equilibrium price is equal to 8, only 6 pizzas are sold. There are people looking for pizzas at this very favorable price of 8, but they cannot get a hold on that. So that is the shortage that we have here. And we are now facing a deadweight loss equal to the pink triangle. So that turns out to be a relation between the size of the deadweight loss and the elasticities of supply and demand. Remember, the elasticities tell you how responsive demand and supply are to price changes, and also for that reason to the introduction of a price floor or a price ceiling. And you can imagine that if prices or if demand and supply are very responsive, that it will lead to a great distortion of how the market would normally function. So in the left picture here, you can see a market for pizzas where both supply and demand are quite inelastic. So they don't respond very much to changes in prices, which means that if in this market if you impose a price ceiling, then it will only lead to a small reduction in the quantity that is supplied. And also, as a consequence, the deadweight loss of imposing a price ceiling in this market will be relatively small. So you have a small pink triangle. Here on my right, you see a market where demand and supply are relatively elastic, which means that if you lower the price by imposing a price ceiling, then many producers will retreat their supply in the market, and you will get a big distortion, you will get a big excess demand, and as a consequence, you will also get a large deadweight loss, which is depicted as the quite large green triangle over here. So these two panels show you the relation between the elasticity of demand and supply and the resulting deadweight loss from a price regulation. Now, we discussed the price ceiling. You can also have a price floor where the policymaker says, well, it's beneficial if the price of a product does not go below a certain level. So that's the situation that's depicted here. Before the price floor was introduced, the equilibrium price was 500 and the equilibrium quantity was 20. Now, for some reason, the policymaker says the price of peanuts cannot go below $1,000, which is good news for the suppliers who are still able to sell pizzas at this higher price. So they will reap a higher surplus, and there will be a transfer of surplus from the consumers to the producers. But at this higher price, there will be many producers who are willing to supply peanuts to the market, but they will not find any demand for these peanuts because the consumers are not willing to pay $1,000 for peanuts. So again, we have a deadweight loss because we have consumers who are willing to pay a price. So we have consumers who are willing to pay a price that is higher than the price that the producers are willing to accept to supply the product, but they cannot engage in a transaction because of the price floor. And that's the reason for the deadweight loss in this case. And we have a situation of excess supply. More producers are willing to supply than there is demand for the product. So the policymaker can set price floors and price regulation. Instead, he can also regulate the quantity by setting a quota. So a quota is a regulation that sets the quantity of a good or a service, and it's often used to limit the input of certain goods. And sometimes it's also used to limit exports. Say, the rare earth metals may not leave China. Vaccines against COVID-19 may not leave some countries, and so on and so on. And the natural question is, what is the impact of quota on markets? How distortive are quotas as measured by the deadweight loss that they generate? Now let's go into that. Similar pictures, but now we don't have a red line on the red horizontal line because we do not fix the price, but we fix the quantity instead. So suppose, for example, that the policymaker says, well, it's not good if everyone in society has a tattoo, and in order to prevent too many people from having a tattoo, we limit the number of tattoos that can be bought every year to, say, 500. Now, in this case, similar story. People who succeed in getting a tattoo, we suppose that these are the people who are willing to pay most for a tattoo, because maybe they are most actively looking for it, and if they will always be able to buy a permit to get a tattoo from someone whose willingness to pay is less. So in the end, we will think that the 500 tattoos will end up with the consumers willing to pay most. But their surplus will be quite low because only 500 tattoos are available. So that creates a situation of scarcity, and that will lead to a very high equilibrium price. So the price is flexible. There's no price regulation here. But given that the quantity is limited at 500, the equilibrium price for which supply 500 equals demand of 500 is equal to 100. So we will observe a very high price. We will not observe an excess demand or an excess supply because at the price of 100, exactly 500 people are willing to buy a tattoo, and that's exactly equal to the supply. So no excess demand or excess supply, but we do have a significant deadweight loss because of the quota, because there are many people who are willing to pay more for a tattoo than the producers actually want to have for supplying the tattoo, but because of the quota, it cannot be. And we have a deadweight loss equal to the triangle C plus E. And more locally, so also in the municipality of Groningen, in the city, regulations are in place. So one regulation that may have hit you is that the number of houses of which rooms can be rented to students is capped at 50% in a given street. And as you saw in the previous graph, if you create such a quota, you create scarcity, and it will lead to higher prices. So because of this regulation, which the municipality has probably installed because they want to have a mix of people living in neighborhoods and not having student-only neighborhoods, but the cost of this regulation is that the prices of student homes go up and are much higher than they would be without a quota. Then the quiz. Try to answer the following question. Suppose that demand is given by 100 minus P and supply by P, very simple supply function. What is the deadweight loss if we impose a minimum price of 60? And the second question, what is the consumer surplus and what is the producer surplus in that case?